Hello. Thanks for stopping by. I thought we'd continue on where we were before and take a look at another power supply. When I started getting back into this hobby, I probably did what most did and took and bought a little LM317 power supply. And of course, it soon became evident that that was basically worthless. It was hard to even get 1 amp out of it. The voltage wouldn't remain constant. It's not a constant current source. So since I decided that I was probably going to stay with the hobby, I started looking around for bench power supplies. And of course, when you look at the less expensive bench power supplies, the first ones you find are the 30 volt 5 amp ones. Well, when I started looking for them, the switch mode ones were like $79, $89, and I didn't really want a switch mode. I wanted a linear, and the linears then were like $150. Now they have come down in price now, but also come down in quality from what I've seen with some of the teardowns or whatever. So I started looking around and seeing what else was available, and I came across uh, this little unit, which is a DP30V5A. It's a 30 volt 5 amp programmable power supply, they call it. It's actually a buck converter, and it's constant voltage, constant current. You can take and set power limits, all sorts of different settings you can take and do with it. So that was one part that I needed. Of course, next thing you need is a transformer for a linear power supply. And I started looking, and most of the, if you get like the 24 volt center tap transformers, they were ridiculously priced. But I came across these, they're Altronics T24 28 175. And I think they're used in security systems or whatever. They're not center tapped, but I didn't really need a center tap. And they can be had now for as little as $20 a piece. When I took and picked mine up, I actually got two of them for $29 shipped. And you usually get at 24 volts. At 24 volts, they're rated at 7.25 amps, which is more than enough for the 5 amp power supply, plus a little extra to take and run the fan. Now, of course, the buck converter is looking for DC, so you have to take and make up a rectifier board. Just simple, diode bridge and one capacitor is all you need. You can use either four separate diodes, or you can take and use a 10 amp bridge. I use 10 amp, for that. I always like to go higher, that way you're not stressing the components. And at the time, I won an auction for four 10,000 microfarad 35 volt caps. So I took and used four of those in a series parallel combination. So basically, I have 10,000 microfarad at 70 volt. But you can take and buy just a single 10,000 microfarad cap, and that'll work fine. That'll give you 34 to 36 volts output, which is more than enough to feed the 30 volt buck converter. Of course, you're going to need a case to put it into. And the case I decided on, because at the time the price was right, was this one. Had more than enough room to take and mount the transformer, the rectifier board, and mount the power supply in the front case, or in the front face of it. I put an on-off switch for the power, and also, you'll notice that in the picture, it looks like there's a second power supply on the right-hand side. That was an experiment I did since I had room in the case. I took and mounted an LT1083 power supply in there that I took and bought as a kit. But evidently, the reason they're selling those kits, or were selling those kits at that time so cheap, is because the LT1083s are garbage. Voltage, you can take and crank the voltage up and down fine, But as soon as you take and try to start drawing any power out of it, it just takes and drops down to 2 volts and stays there. So that's worthless. What I may do in the future is take that out and take and put L7809 and 7805 regulator. They have, a constant 5 volt, constant 9 volt, probably constant 12 volts. Now, like with any power supply, you want to make sure that you have enough ventilation. Now, this particular case that I used has ventilation on the sides. I also took and drilled ventilation holes in the top just above where the buck converter goes, because it has cooling fins on it there, and that way it would go over those cooling fins and out those holes. Then on the back panel here, I took and mounted the fan and an IEC connector. Now, I highly recommend using this type of IEC connector. It has a built-in fuse, and that way you don't forget to take and put a fuse in like some people seem to do in certain equipment. And I've had no trouble with them. It just takes, just a slightly larger hole in it and everything. The other thing you have to watch out for is if you look at this case, the white is plastic and all the screws go into the white plastic, which means that none of the metal pieces are electrically connected. So what I did is I took and ran the ground wire to a T, and then took and ran wires from that, and then have wire attached to the top, to the front, back, side, so that everything is grounded separately from the rest of it. It's been a very dependable power supply. I've never had any trouble. That side of it I've had no trouble with at all. It was just that LM380 side that I have trouble with. So I hope this gives you some idea of, ways, another way to make your own power supply. And thanks for stopping by. Just remember everybody that the Keystone contest for test equipment goes on the entire month of March, and you can take and enter daily. So don't forget about that, and good luck, everybody.